We've taken a look at vectors in general terms of a magnitude and a direction, and taking a look if two vectors are equal to one another. And now we're going to take a look at specifically naming and identifying vectors. So looking here, we're going to be using more letters of the alphabet in this section, and we're introducing this idea of using I and J. Our I information is going to be with the x-axis, and our J information is going to be talking about the y-axis. So this I here, this vector I here that you can see, is going to be a unit vector. What a unit vector means is this vector has length of 1, and you can see this. From 0 at the origin, from 0 to 1, that length is 1. So that's what vector I means. It has a length of 1, and it is in the direction of the x-axis. J is comparable on the y-axis. J is the unit vector, again, the distance from the origin 0 to this point here, its ending point of the vector is 1. So its magnitude is 1, the distance is 1, and J defines movement along the y-axis. So I and J are going to be telling us about x and y direction. So we're going to be looking at vectors that have an initial or a starting position at the origin. So we're looking at vectors that start at the origin 0, 0, and then go to their ending point, or their terminal point is some x, y that we're just going to call A and B. And taking this vector information and writing it as an equation using I and J is going to look like this, where this vector V is going to be the information in front of the I, which remember is x direction, is going to be A from the x here. So remember xy, and then this is x, y. So the B, the y information from our ending or terminal point, is going to be the number there in front of the J. And here it says A is the horizontal component, or the x direction component of the vector, and B is the vertical component of the vector, or the y direction. The magnitude, so magnitude here of this vector V is going to be defined as the square root of A squared plus B squared, which you should remember, this is the distance formula, and we don't need to do the x1 minus x2 here because we're starting at the origin. It's going to be x minus 0, and then for the y piece, y minus 0, so we don't have to write out that subtraction for the full distance formula. We can just go to a squared plus b squared. But remember, this is the distance formula, the difference in x and the difference in y squared. But being that our x and y are 0, we're sort of shortcutting the subtraction process. So in this example, this first example we're going to look at, what we're going to do is to sketch this vector v that's given to us as 3i minus 3j. So the x information is 3. So we're going to go 1, 2, 3 here. And now the y information is minus 3. So we're going to go to our x is 3, and then down here to minus 3, and that is going to be the terminal point of our vector. We're starting, the beginning point, the initial point is the origin. So there is our vector, and I'm going to show the direction by putting that little arrow in to show we're moving in this direction from the origin to this point here, which is 3, negative 3. So there's the sketch of our vector. Now the other thing we are asked to do here is to find its magnitude. So using the information from above, the magnitude of this vector v is going to be the square root of a squared plus b squared. In our example, A is 3, so this is going to be 3 squared. B is negative 3, so negative 3 squared. All of this is under the square root. So now we have 9 plus 9 is equal to the square root 18. And we can simplify this. So 18 is 9 times 2. Square root 9, square root 2, which would be 3 square root 2. So the magnitude of this vector v is 3 times the square root 2. So again, magnitude, that's the length of this. And we've shown the picture of this. Next thing we're going to look at here is if we are given 2 points. So we're just given the initial point, which we're going to call P1, and the terminal point, P2. And now the coordinates for P1, x1, y1, and the xy coordinates, x2, y2 for point P2. So if we're given the initial point of a vector, the starting point, and then the ending or the terminal point, we can express these 2 points in terms of a vector using our I and j like this. Vector v is going to be the difference between x2 and x1, and that goes in front of I, and in front of j, we're going to have y2 minus y1. This order is very important. The order here is important. It has to be terminal point minus initial point. So it's x2 minus x1. There's no choice here. It has to be terminal minus initial point. Example, we are given the initial point for some vector, which is -1, 3, and we're told the terminal point is 2, 7. And our mission here is to come up with what this vector v looks like in terms of I and j. So vector v, and I can't, as I said last video, I can't write in boldface, so vector v is going to be x2 minus x1 I plus y2 minus y1 j. So there's the general formula. Now we put in our specific values. So for our x2, so let me identify them here so it's clear to you. Here's P1, x1, y1, P2, x2, y2. So our x2 is going to be 2 minus from this formula, and now our x1 is -1. So we end up with this thing like this negative here. And then for our j information, we have y2, so we have 7. And now y1 is 3, so we have 7 minus 3, j. So for I, we subtract our x information, and for j, we subtract our y information. So here now, negative is positive, so we have 2 plus 1. So we have 3i plus 4j. So that was what we were to do here. Just take the points and come up with it in its vector form using I and j. Remember, I is the unit vector in the direction of the x-axis, and j is the unit vector in the direction of the y-axis.